Hello and welcome back to another episode of Effective JaRu, the series where we will read effective Java, skim through it basically, and try to implement the items in idiomatic Rusts. It's now time for a little review of the previous one, because actually I wanted to do something but I forgot, damn it. Yeah, well, at least I knew I wanted to do a review. I wanted to add something super interesting. I think parsing, right? The calculator. Where is it? Item 30, calc. Excuse me. Let me get that in a moment. Here it is, bin calc. I don't know why Sublime Text didn't want to find that. Maybe because it's in bin folder and bin is excluded. Anyway, something like that. The thing is, we have just stupidly implemented no, not the weight table, the operation implementation here, even though for some reason there is a conversion from the operator to the item here, to the variant, and it's not used at all. And I think, well, why should we iterate all of this if we can more easily just parse the operand as well? So let's do that. So let operand be our operation. So we now include self as well. That should be the syntax for this. No. Okay, so you have to do it separately. And on the other hand, we don't need the other stuff anymore anyway. So the op is still there as it was before. And the code actually doesn't change except for maybe the comment here. So second argument must be the operation. For example, plus. Let's turn off the word wrap here for a moment. And a third argument must be the second operand. That is true. So now we should have everything to make this work. Let's see. Run calc. So this should now fail because value 2 is not a valid operation. Reminds me of me wanting to put that into parentheses or into some backticks or ticks. It's always a good idea to do that, then you know exactly what was wrong there. So, I didn't save that, no? So now we are back and I should be able to say 1 plus 2. Yay! 1 minus 2. Yay! So isn't that great? So easy. And we didn't do anything to achieve that. And I thought, damn it, the Java version could have done the same. Oh, look at this. Oh yeah, I think this doesn't really work well because it's taken by the shell. And yeah. So we are in debug mode here. So if we get oh no, it's double, so we don't get a overflow at any point. We might get infinity, but I don't know how that is possible with numbers. We might try to do some division by 0 though. Okay, then we get infinity. Makes sense. And that is that. Let's look at the other items because I don't think lots of them will be ported. So here we go. The ensemble. The ensemble. The issue that item described here is basically don't use ordinals, because ordinals in the constructor are bound to the order of the thing, and that's usually relatively unflexible. Even though it seems to lend itself, you don't want to do that. Instead, be specific. Just drop in the number here and you're good. In Rust, you don't have anything like that. There is no way to determine the the number there or the order of the item or the index of the item. I think of the variant. That's what I want to say. So the text here is another example that shows how to use enumerations within a set. So usually you do something like bold and italic to basically set bit flags in an integer or something, and then you can easily work with that. But that isn't suggested. In fact, it's suggested to support a set of styles, and then you can use an EnumSet as an implementation of a set, which is a optimized version. In Rust, you can do the same thing. Obviously, you can use a set that is generalized over your over your style there. We could implement this and show how this works, just so that, yeah, why not? Because there is quite an equivalency there. So we have a pub enum text that understands the style. Sure, let's call it text style right away. I'm kind of simplifying this. I don't want to have two types here, just want to have one. And then I show in a test how you can use it. I think that's more like it. So we have bold. Oh, we have bold, italic, underline, and strike through. There's not much to it really. And oh, it's an untitled file. Look at me. I probably want to have an item 32 somewhere. Cargo new item 32. Item 32 lib. There we go. Okay, so now I think it's time for a test. Test with style. And what could we use here? We could use a collection B-tree set, maybe, because it's a set. That's all we are interested in. And now I can, well, add some items there. We can, we have a from iterator trait that we can use to our advantage here. I just wonder how it's called, how the function is called. It's from iter. So yeah, we should be able to do to get a map here that is a B-tree set from iter. And you see, I didn't specify a type just yet because I think the type can be pretty much inferred by this. Let's see. Let's try that. Wait a moment. That could actually. Yeah, we might want to use a vector so that it's converted, so that it's strained basically. Because we want the items to move into the B-tree set. Otherwise, you might deal with references here, and that might be a problem. Anyway, so we have text style bold and text style italic. And ideally, that yields a mapping of these things. And we should be able to check for whether or not it's included. Let's try to build it real quick. Cargo test lib. Ready? Collections. No associated iter named from iter found for type. Okay, maybe I have to import that one, std iter from iter iterator. I'm not sure. Std iter from iterator. Let's see. Oh yeah, it actually told me candidate is this. And now, or it is not implemented for type text style. Oh, yeah, in order for it to be in a set, you need that. I think for this to work, you need hash code implemented, which is auto-implemented by enumeration. Makes sense. We will auto-implement it as well. Partial, ord, and ord. I think that's more like it. and equality and partial equality. So let's see. We're getting somewhere. Cool. So now we have a set of these items. It is optimized. You know, it's as small as it gets. It's as simple as it gets. So there's no need for a special EnumSet here to work with bitflex internally. Even though doing so might be a good thing, but not in our case. So what else? Assert. Yeah, let's see what the interface is. Do we have contains? B-tree set that returns a boolean or something? Oh yeah, we have that. Nice. Assert m contains text style. Now I wished I had imported these variants. And it also contains italic, but it shall not contain underline. So that should all be true. And it is not, because I didn't negate that. So there we, because I didn't negate that. Think before you act, I guess. There we go. So that totally works. So that's kind of the Rust way of doing this. You could also implement the OR operator. I think you could implement some real bitflex yourself. But obviously, in the moment you want to take them, you would, yeah, I don't know how it would be, you know, if you would be able to do something like this, then you must be, this must convert into something, and I'm not sure what comes out of there. I think bit or is defined to return the item itself. So I don't know if that can be working. I don't think it can be working at all without converting that stuff into an integer or something, which can be done. I think you can do this, right? I don't know what that means actually. I've never used it like that. This probably means that you can use it as int or something. Let's try that. I've never done that. Text style. Bold. So is it now an int or something? I32? Does that work? That does work. That is quite amazing. So bold we have assigned. What's underline then? Underline is just... And let's assert false here. Three. I see. So we can do all the fanciness, huh? We can do this, and we can do this, and... Is there an iota, by the way? No, there's nothing like that. So let's see how that looks like now. Well, and if that works, does it all, or do I have to convert it even? Probably not. Oh no, I do have to. Okay, does that work as well? Text style, well, it should, huh? Sure, I can now put them together. Underline as I32. It's no fun to use it though, because of these conversions, and it shows how inherently unsafe that is, I suppose. Because you lose basically your type information, and I don't think you want to do that anyway. So I would be okay with using sets in order to mark what you want, but yeah, I wouldn't go down to the level of bitflex there. Maybe there is a crate for that does that. Let's see. Is there something with bit in the name? Bits. Bitsys, bitset, a vector of bits, bitvec, a vector of bits. Okay. Something. Yeah, I don't know. I've never seen that in Rust ever, but I certainly would like to, what the standard Rust way would be there. So, yeah, it's a short episode, 15 minutes, but it's fine. Thanks for watching and have a great day.